Okay, so this is part 3 of the UV-VIS analysis. We calculated more or less accurately the 3 concentrations that we're after here: the acetone, toluene, and ethyl acetate values. But it was tedious, right? So let's try to figure out a different way to do this. And that would be to use the 3 values in a matrix multiplication format. So this is based on the idea that A equals epsilon C, right? If we omit B here, right? So, and this is also true of matrices, right? So what we need to find here is a matrix so that we can C is equal to E minus 1 times C, right? And E minus 1 is the inverse of a matrix. And the inverse of a matrix is not just the inverse of each individual component, right? So, C is equal to epsilon inverse A. Oops. Huh. I gotta kill the superscript there. And, oops. A. There we go. Oh, how weird. Anyway. So, so let's just see about this, right? The extinctions here, these are our 3 by 3 matrix, right? And let's see if we can invert that matrix. So I'm going to make a 3 by 3 region here, and I'm going to call that, or I will program to be the M inverse of that matrix there, and we'll see how that works. So it inverted, fine. There's no crazy huge numbers in there, so that is our epsilon inverse matrix. Right? So this calculation can then be right multiplied by the absorbance to get the concentration. And so I'll just copy this matrix over here. And I will clean up the sig figs here just a little bit. I think I'll just make numbers out of them. There we go. And I'll make a little thingamajinger around them there. Center that. Make a little thingamajinger there. I'll make an equal sign. You need to put a single quote in there. And then if this is the right order, then this matrix should be the M mult of this guy, and that's a comma, that guy there, and there we go. There we go. 0.0080, 0.0042, 0.0083. Beautiful. So this will be our calculation result. more sig figs than we deserve, I think. 8043 or 8043 and 83. So the difference here is that these make use of the very small absorptions at the off wavelength part. So this is cool, but I tell you what's even cooler. And what is even cooler is to find what concentration set makes this blue the sum of a coefficient times the black, the dark blue, and the red. And that is called Linest. So let us move on to the next here. Oh, I see, and this is going to be acetone, toluene, and ethyl acetate. So let's try a Linest example. Right. So I'm just going to type equals Linest. For the Y matrix, oh, you know what? I just realized something here. I need to make these columns into extinction coefficients here. So I'm going to insert two columns here. Then I'm going to say, first we'll start with acetone, and we'll divide that by the acetone concentration, right? And I'll use F4 on that. And this I'll make equal to ethyl acetate over the ethyl acetate concentration. I'll F4 that guy. And this guy I'll make equal to the toluene absorbance divided by the toluene concentration. And I will use F4 again there. And so I'm just going to, so now these values are now extinction coefficients, right? And so what I'm going to do is I'm going to copy this equation down. Oops, I've got to go all the way down here. All right. And there we have extinction coefficients for at every wavelength for the three analytes, right? So this will be EPS for acetone. This will be EPS for EA. And this will be EPS for toluene. And what I would like to do is find those coefficients, which times epsilon equal absorbance. In other words, the concentration. So I will put my cursor there, and I will say equals Linest. I'm going to put in the known y values, right? The known y values, I would like to start at 230 and end at 320. So these y values, I'm going to come down to 320 here. And I'm going to put in the y values are the absorbances of the mixture. And I'm going to use Control-Shift-Arrow down. I'll go to the bottom. And then I will come up here to 230. So that's going to be row 173. Then the X values, I will choose the epsilon values, right? Oops, and I have to actually use shift and come down here all the way to the beginning of the, there we go. Oops. The beginning of the data up here. So that's going to be row 83, right? And I'm going to say no or false and true. So false is I don't want a b. I just want y equals mx, or in this case 3 m values. And then the true is I want some additional statistics. And I will push enter, and then here is my LINEST. And you will notice we got a 3, an 8, and an 8, and that is correct. The identities of these will be toluene, ethyl acetate, and acetone in most cases, right? So actually, I'm going to move this down just a little bit. And so this guy here will be toluene. This will be ethyl acetate. And this will be acetone. And these are uncertainties, right? All right, so these are the concentrations here, rather. So we want to give them the proper sig figs, right? And here are the estimated uncertainties in those values. And we also want them to be numbers. We've got to give them more decimals. And I'll give them one more there. Give our sigma values, these are sigma values, I give them 2 sig figs. Okay. So here are the, here are the values and the uncertainties. Right? And so this is another calculation, right? These are our calculated values. So 806 or 0.8%, 0.8%, and 0.4% there for those 3 values. So this this is how we do this. And this is all you need. Just understand what you've calculated in each of these cases, and you are done.